Hey y'all, so I'm back with part 2 of part 3, right? Yeah, this is because my phone cut off on me. And so if we have enough space, I'll do a little jam session after this is done, and you can check that out. That should be good, maybe. It might be horrible. All right, so where we left off, I was saying we found 319. Check out part 3.1 first before you watch this. 319 torr. And the problem told us the solution had 260 torr was its vapor pressure. So we're comparing these now. 319 to 220. And the question was, is this an ideal solution? Yes, no, or no negative, no positive. What's all this mean? Well, if it's ideal, this equals this. What we find equals what they give. They gave 260 as total vapor pressure. They're not the same. It's not ideal. So you can blot that out. Is it negative or positive? Well, this has to do with a deviation. And so this question, I need to get my book, y'all, because I don't remember this exactly. Page 429. Is this negative or positive deviation? This one is actually, what is this? This is a negative deviation. Why? Why is this a negative deviation? Because the observed vapor pressure, we observed 260, was lower than the expected value. We expected this. Now you might say, well, I thought we expected 260. I said the same thing. But actually what you find is what you expect it to be. But what it gives is what is observed. So if what is observed is lower than what is expected, observed, expected, then you have a negative deviation. Now if this number was like 210, it would be a positive deviation because you observed this, you expect this, observed if this was 210, observed would be 260 and higher. So it'd be a positive deviation. What does this deviation stuff mean? So goes back to this little graph here. All right, so this is an ideal solution. Now don't get caught up in the graphs, but just know be able to recognize that this is a positive deviation. This is a negative deviation. Now let's talk about that real fast. So basically this answer here refers to a negative deviation because this is lower than expected. Now, how do we know what's negative? If you looked at these graphs and I said what's negative and what's positive, the only way I like to look at it is these curve up, right? These are curving up. So positive, this is a higher number at this little peak than the other value. So basically this peak here, where it kind of peaks out, versus this is a higher value. It's peaking basically like that, you know, it's curving that way. This is peaking like downward. So just think this is peaking up, so it's positive. This is peaking down again, so it's lower. This is peaking up, it's a hill. This is like a hill, this is like a slope. So the hill or the mountain is positive, it's high. The slope down, the curve down, this is a negative, this is low, this is high, mountaintop, positive. Now the weak and strong, what's that mean? This means strong interactions, this means weak interactions. So when you have a negative deviation, that means you have very strong interactions between these two things, acetone and chloroform. So in this case, these have very strong intermolecular interactions, which keeps these two things in here. Let's put two of them in there. Both are in there equally, right? We found them to be equal, 0.5 mole fraction. These both have a very strong interaction, so they are not going to want to release into the gas stage. They're really strongly bound. They don't want to release into the vapor stage. They don't want to evaporate. So that means that their vapor pressure will be lower than expected, which it was 260. It's lower than expected, so it's low. It's negative deviation. It's very strongly interacted. If it's positive deviation, they're weakly interacting, very weak bonds in here. So they're not held together, and they just freely go up into the vapor state, causing high pressure down, more vapor pressure, very weak interactions, higher vapor pressure than expected. So this number would be higher than that number in this case. So that's why this is higher. It's peaking up. This is sloping down here, you know, almost like a concave and convex, like in ChemLab, you know, the meniscus thing. You know, this is down, this is negative. These are really strongly held down together. These are not held together, they're loosely connected and they go up easy. So this one, 319 versus 260, you know, this one's negative. It's very strong interaction.